Let us talk about negative binomial distribution. So this may be useful if you are preparing for MA Economics entrance. It can serve as a basic. Or if you're preparing for an Indian Economic Services, you can get a question like write a short note on negative binomial distribution. So it may be useful to you as well. Or if you're preparing for your semester stats exam. So it is useful that if you know how to differentiate between the binomial and the negative binomial distribution. So negative binomial distribution. So let me just remind what exactly binomial distribution is. So let me just take you back. You flip a coin 2 times and you want to count how many times head has appeared, right? It has a fixed number of trials. You flip a coin 2 times. This is binomial. This is not negative binomial, mind you. I'll be distinguishing it from negative binomial. So you flip a coin 2 times and you're counting how many times head has appeared. It has fixed number of trials and equals to 2. Right? Each trial can result in only 2 possible outcomes. Head or tail. Each trial is an independent event. So if you're getting head on the first trial, the outcome of the second trial is an independent of whether you've got head or tail in the first trial. So that is true. Your question was, you flip a coin 2 times and how many times head is going to appear. Probability of success P for each trial is constant. So probability of getting head, let's say you call that as success. So probability of getting head on each trial is constant. In this case, it is 1/2. That is constant. So this is what the binomial distribution is. But supposedly, how do you distinguish it from the negative binomial distribution? Mind you, there is not much difference between them. The difference is just this, that in case of negative binomial distribution, you have the stopping rule. You have a stopping rule even in the binomial distribution for a way. I mean, because in binomial distribution, what happens is that you are given with a fixed number of trials, right? You're saying after 2, for example, in the question which we have, you toss a coin 2 times, how many times head is going to appear, right? It is telling you the number of successes K achieved in N trials. So your success is getting head, achieving this in 2 trials, where probability of success is P. This is what it is telling you. Negative binomial tells you what? Negative binomial tells you that it is telling you that you will be repeating the experiment till you get 2 heads, right? So how many, it describes the number of successes K until observing R failures, where the probability of success is P. So you'll be repeating the experiment till you are going to get, let's say, 2 heads or 5 heads or whatever it is. So there's a stopping rule. Both of them are replacement, right? Both of them are telling you the distribution of draws with replacement, but the difference is the stopping rule. So the experiment is going to continue till you are going to get 2 heads. So for example, if on the first 2 tosses of coin, you are not getting any head, experiment will continue. In case of binomial, it will stop. Even in the 4th try, you are not getting 2 head, experiment is going to continue. So it will continue till you are getting 2 heads. So that is what negative binomial is. For example, you flip a coin repeatedly and you count the number of times the coin is going to land on head, right? You continue flipping the coin until it has landed 5 times on head. This is negative binomial. Why? The experiment consisted of repeated trials. Yes, you'll be repeating the experiment till you are going to get 5 heads. Each trial can result in just 2 possible outcomes, head or tail, right? Just 2 possible outcomes, head or tail, success or failure. The probability of success is constant. The probability of getting head in a toss of a coin is what? Half. That is constant. The trials are independent. The probability of getting head on the first trial is not going to affect the probability of getting head on the second trial and the third trial and so on and so forth. And the experiment is going to continue until a fixed number of successes have occurred. So here you are asking how many, you are fixing the number of success and you're going to repeat the experiment till you are getting that success. You're fixing that you are going to get success 5 times. How many times that experiment has to be repeated? In binomial, you are fixing the number of trials. So that is the difference. So in binomial, you stop when the number of trials which you have fixed, you have done that. In negative binomial, you're going to stop till the success which you have fixed, that is going to be achieved. That is the point. So X is the total number of trials which you have. R is the number of occurrences of success. P is the probability of success on each outcome. And you write this F function as the negative binomial probability. It is nothing. It is just telling you the probability that an X trial, you don't know how many number of trials, result in the rth success. So in our example, the probability that the X number of trials have to be done so that you can achieve R success. R success here would mean you're getting 5 tosses of head, right? And when the probability of success is P. So in our case, the probability of success is P. P is what? Your probability of success. So in our case, it was half. NCR is number of combinations of n things taken R at a time. Taken R at a time. So how do you write basically your negative binomial distribution formula? You write it like this. So you write it like that probability is X minus 1 C R minus 1 P to the power R 1 minus P to the power X minus R. 1 minus P to the power X minus R. So this is the probability of what? Probability of the binomial experiment or of the negative binomial experiment, which is consisting of X trials, resulting in R successes. Resulting in R successes. So in our case, we don't know how many trials would be needed to get 5 heads. And the probability of success is P. So in our case, P is equal to half. That is what it is. So that is the question. That is the question. So let's say, let's look at one simple example. Suppose that a basketball player is an 80% free throw shooter. So this probability is fixed and this is given to you. Also assume that making one free throw is independent of making the next. So this is satisfying the property of negative binomial. The probability, the throws are independent. One experiment is independent of the other. What is the probability that for this player, the 8th basket is made on the 10th free throw? What is the probability that the 8th basket is made on the 10th free throw, right? So you will be repeating the experiment till he gets 8 successes. Till he gets 8 successes. So there is a constant probability of success. There is a constant probability of success, which is 0.8. And The probability of failure is 0.2. So we want to determine the probability of x equals to 10 when r equals to 8, right? We want to determine the probability that he will be making his 8th basket on the 10th free throw, right? So what is the probability that for this player, the 8th basket is made on his 10th free throw? So for example, I mean, in this case, it is going to be what? Your x minus 1, c r minus 1, t to the power r into 1 minus p to the power x minus r. So 10 minus r, 10 minus 8, that is 2. So once you solve this, you'll be getting 24%. Once you solve this, you'll be getting 24%. So you can also write one more question. For example, you can think of the question like this. So you are surveying people after they have voted. You're surveying, I mean, what do you call your exit poll survey? And you're asking them whether they have voted for party A or not, right? The probability that the person has voted for party A is 20%. So that probability is fixed. Okay. So what is the probability that 15 people must be asked before you can find 5 people who voted for independent? So that is what negative binomial is. So 15 people must be asked before you can find 5 people who have voted for independent, right? So here, here x is what? X is 15. R is 5. That is what your success is. Probability is constant and they are independent. So you are given with, so you'll be finding out, how do you write this? That probability is 20% or 0.2. R is 5. So how do you write this? I mean, what is going to be the probability? That is x minus 1, c r minus 1, p to the power x, 1 minus p to the power x minus r. Like this. P to the power r, not x. So x is 15, so it is 15 minus 1, c5 minus 1. Probability of success is constant. Number of successes are 5, 0.8, x minus r, that is 15 minus 5. So what is going to be the case? This, I think this is going to come out to be 0.034. That is 3.4%. So this is what negative binomial distribution is. Chaliye, thank you, beta.